Hello everyone, and welcome to this week's special episode of Log Cabin Mysteries. For we have breaking news, this just in from the Pentagon's UFO Director Sean Kirkpatrick. It has been announced that it is possible that there is an alien mothership in our solar system. This announcement was made through the publishing of a draft document and was announced by Mr. Kirkpatrick. Now, I will read to you the following document. Draft version, March 7, 2023. Physical constraints on unidentified aerial phenomena. Abraham, Avi, Loeb, and Sean M. Kirkpatrick. Head of the Galileo Project, Astronomy Department, Harvard University, 60 Garden Street, Cambridge, Massachusetts, 02138, USA. Director of All Domain Anomaly Resolution Office, 1010 Defense, Pentagon, Washington, D.C., 20301, USA. Abstract. We derive physical constraints on interpretations of highly maneuverable, unidentified aerial phenomena, UAP, based on standard physics and known forms of matter and radiation. In particular, we show that the friction of UAP with the surrounding air or water is expected to generate a bright optical fireball, ionization shell and tail, implying radio signatures. The fireball luminosity scales with inferred distance to the fifth power. Radar cross-section scales similarly to meteor head echoes as the square of the effective radius of the sphere surrounding the object, while the radar cross-section of the resulting ionization tail scales linearly with the radius of the ionization cylinder. The lack of all these signatures could imply inaccurate distance measurements and hence derived velocity for single-site sensors without a range gate capability. Keywords: interstellar objects, meteors, meteoroids, meteorites, bolides, asteroids, general, asteroids, individual, minor planets, Oumuamua. 1. Introduction. In 2005, the U.S. Congress tasked NASA to find 90% of all near-Earth objects that are larger than 140 meters. The congressional task resulted in the construction of the Pan-STARRS telescopes. On October 19, 2017, the Pan-STARRS Sky Survey flagged an unusual NEO, the interstellar object Oumuamua. See Loeb 2022a and references therein. Unlike solar system asteroids or comets, Oumuamua appeared to have an extreme flat shape and was pushed away from the sun without showing a cometary tail of gas and dust, raising the possibility that it was thin and artificial in origin. 3 years later, Pan-STARRS discovered a definitely artificial object, namely NASA's Rocket Booster 2020, SO, which exhibited similar behavior with an extreme shape, a push by the solar radiation pressure, and no cometary tail, because its thin walls were made of stainless steel. On March 9, 2017, 6 months before Oumuamua's closest approach to Earth, a meter-sized interstellar meteor collided with Earth. Surprisingly, IM-2 had an identical speed relative to the Sun at large distances, and an identical heliocentric semi-major axis as Oumuamua had. But the inclination of IM-2's orbital plane around the Sun was completely different from Oumuamua's, implying that the two objects are unrelated. Nevertheless, the coincidences between some orbital parameters of Oumuamua and IM-2 inspires us to consider the possibility that an artificial interstellar object could potentially be a parent craft that releases many small probes during its close passage to Earth, an operational construct not too dissimilar from NASA missions. These dandelion seeds could be separated from the parent craft by the tidal gravitational force of the Sun or by a maneuvering capability. A small ejection speed far away could lead to a large deviation from the trajectory of the parent craft near the Sun. The changes would manifest both in arrival time and distance of closest approach to Earth. With proper design, these tiny probes would reach the Earth or other solar system planets for exploration as the parent craft passes by within a fraction of the Earth-Sun separation, just like Oumuamua did. Astronomers would not be able to notice the spray of mini probes because they do not reflect enough sunlight for existing survey telescopes to notice them if they are on the 10 centimeter scale of CubeSats or smaller. At a distance d from the Sun and the telescope, objects that are a meter in diameter and reflect a fraction of A estimated to equal 10% of sunlight impinging on their surface would yield a flux of optical light of around 0.2 in parentheses d over 1 AU to the negative 2 power, lowercase n, uppercase j, lowercase y, well below the detection threshold of even the James Webb Space Telescope. In contrast, the radar signatures of a meter-class object would be detectable with our deep space radars in Space Fence, much like IM-2 was, out to beyond geosynchronous orbit at an altitude above 36,000 kilometers. Such objects could also become optically detectable as they get close to Earth, especially if they create a fireball as a result of their friction with air. Equipped with a large surface-to-mass ratio of a parachute, technological dandelion seeds could slow down in the Earth's atmosphere to avoid burnup and then pursue their objectives wherever they land. Current radar coverage of the majority of first-world countries gives detectability of this high area-to-mass objects down to a few centimeters, depending on material, making detectability possible. Within a close range to a star, extraterrestrial technological probes could use starlight to charge their batteries and liquid water as their fuel. This would explain why they would target the habitable region around stars, where liquid water may exist on the surface of rocky planets with an atmosphere, like the Earth. Habitable planets would be particularly appealing to transmedium probes, capable of moving between space, air, and water. From a large distance, Venus, Earth, or Mars would be equally attractive for probes, but upon closer inspection, Earth would show spectral signatures of liquid water through reflection of blue light, and vegetation through its red edge that might attract selective attention. What would be the overarching purpose of this journey? In analogy with actual dandelion seeds, the probes could propagate the blueprint of their senders. As with biological seeds, the raw materials on the planet's surface could also be used by them as nutrients for self-replication or simply scientific exploration. It is important to note that given the time scales associated with the propulsion scheme discussed here, it is unreasonable to assert that the intention of any such probe launched in the far distant past has anything to do with the human species. More likely, and similar to NASA's mission, the goal would be scientific and exploratory in nature. Based on the detection rate of interstellar objects, Siraj and Loeb estimated that for every interstellar NEO, there are 1,000 solar system NEOs of the same size. Searching for interstellar meteorites among the many more meteorites from the solar system without information about impact velocity is like searching for a needle in a haystack. This is why the first interstellar meteor, IM-1, confirmed by velocity measurement of the U.S. Space Command, is the target of a fully funded ocean expedition by the Galileo project. Hopefully, by retrieving IM-1's fragments within the coming year, we will know whether its extraordinary material strength resulted from it being made out of an artificial alloy, like stainless steel, or materials not yet developed by humans. Are there any functioning extraterrestrial probes near Earth? We do not know, but the Galileo Project 2021 intends to use the scientific method to explore this possibility, following the 2021 report about Unidentified Aerial Phenomena, UAP, from the Office of the Director of National Intelligence to the U.S. Congress. The state-of-the-art suite of instruments and computer algorithms of the Galileo Project will be able to study such data in the near future. The search for UAP and the characterization of UAP requires bounding the search plan with physics-based constraints on what we are searching for. This paper aims to constrain one aspect of the UAP hypothesis within parameters that govern the movement and interaction of a UAP with Earth's atmosphere to eliminate or bound observational uncertainties. Some data collected to date, while arising from multiple sensors, have uncertainties or one or more dimensions, leaving the exploitation of the data with a significant range of interpretations. This inevitably leaves open the debate on what some objects are and whether or not they exhibited truly anomalous behavior. Specifically, if some observed UAP are of extraterrestrial origin, there are some practical limits on the interpretation of observed and measured data resulting from physics-based constraints. Number 2, the extraterrestrial possibility. The academic interest in UAP stems from their potential non-human technological origin. Extraterrestrial equipment could arrive in two forms. Space trash, similar to the way our own interstellar probes Voyager 1 and 2, Pioneer 10 and 11, and New Horizons will appear in a billion years, or functional equipment such as autonomous devices equipped with AI. Electronic probes employing conventional chemical propulsion and refueling that we currently understand would be a likely choice for travel within a planetary system. Some combination of conventional propulsion, ion propulsion, or light sail propulsion would provide good choices for crossing the tens of thousands of light years that span the scale of the Milky Way galaxy. Such autonomous systems could be designed to survive even if the senders are not able to communicate with them and deposit probes upon arrival to the target planetary systems. It is likely that any functional devices embedded in the Earth's atmosphere are not carrying biological entities, because these would not survive the long journey through interstellar space in its harsh conditions, including bombardment by energetic cosmic rays, X-rays, and gamma rays. Interstellar gas and dust particles deposit a kinetic energy per unit mass that exceeds the output of chemical explosives at the speed of tens of kilometers per second. However, technological devices with AI can be shielded to withstand the hazards of space, repair themselves mechanically, or even reproduce given the resources of a habitable planet like Earth. With machine learning capabilities, they can adapt to new circumstances and pursue the goals of their senders without any need for external guidance. As argued by John von Neumann in 1939, the number of such devices could increase exponentially with time if they self-replicate, a quality enabled by 3D printing and AI technologies. Physical artifacts might also carry messages, as envisioned by Ronald Bracewell in 1960 and currently used by NASA. Skipping ahead to the conclusion, number 6. Conclusion. The considerations in this paper imply a useful limit on observations of UAP, which bound the hypothetical explanations and can support limitations on interpretations of data. For example, one of the most common sets of data within the military holdings comes from the FLIR, forward-looking infrared, pods. These sensors provide an accurate, resolved image of relative thermal measurements across the scene. Typical UAP sightings are too far away to get a highly resolved image of the object, and determination of the object's motion is limited by the lack of range data. The range is usually estimated using the flight dynamics of the platform and some fixed points in the scene, if either are available. The error in estimating the range gives rise to a significant variation in the calculated velocity and is subject to human bias and error. Claims of objects exceeding the transonic to supersonic range should be evaluated against the above known physics of ionization, radar reflectivity, temperature, sonic booms, and fireballs, all of which can more effectively and accurately bound the velocity and hence drive the range calculation. This will in turn, when matched with the specifics of the sensor, allow for better estimates of the size, shape, and mass of the object in question. Wow, that was quite a paper, was that not? Let us know in the comments what you think below. Do you think Oumuamua was an artificial mothership sending out probes? Or do you think it was simply a natural object? Do you believe extraterrestrial civilizations may be sending probes to Earth in the manner suggested? Let us know your thoughts below, and thank you for joining us on this special episode of Log Cabin Mysteries. Have a good day.